In this video, we will give an introduction to descriptive statistics, focusing on definitions and foundational ideas. What is descriptive statistics? We present a basic working definition. Descriptive statistics is the science of collection, organization, and summarization of data with charts, graphs, and/or numbers for the purpose of understanding the nature of the data distribution. The distribution of a variable is the collection of values taken by the variable and the frequency with which those values occur. Let's consider numerical distributions. A density curve describes the overall pattern of a distribution, with the horizontal axis representing the values the variable takes, and the area under the curve representing the relative frequency with which those values occur. One characteristic we want to summarize is the shape of this curve. Is the curve symmetric, skewed? Does it have one peak, multiple peaks? Is it flat? In general, to summarize a numerical distribution, we want to describe three features of the distribution or density curve. These features are shape, center, and spread. We already mentioned the shape of the curve. The center of a distribution is a measure of a typical observed value. These measures are also called measures of location. One very common measure of the center of a data set is the mean value. The mean is the well-known arithmetic average. This value adequately measures the center of the data set if the distribution is not skewed and does not contain any outliers. If the distribution is skewed, the median provides a better measure of the center. The median is the middle value when the observations are arranged in numerical order, or the 50th percentile. The mode, or most frequently occurring data value, is another relatively common measure of a typical or average data value. We should note that there are many other ways to appropriately measure the concept of average in different situations. When an average is given in a report or a news account, it's important to consider which version of average was used. For example, average salaries or incomes are almost always median values because the distribution of American incomes or salaries is quite skewed to the right. The center of a distribution doesn't always tell the whole story. We also need a measure of spread to describe how far from average the typical observation falls. Here's an example. I once taught a calculus class with 11 students enrolled. On every test, the mean score was about 75. It could have been that all 11 students were scoring in the 70s. In this case, the data would not have been very spread out. However, what actually occurred was that on every test, 5 students made A's, 5 students made F's, and 1 student who rarely attended class would show up and pull a C. This distribution is quite different from a class in which every student made a C. Like measures of locations, there are a variety of measures of spread. The most common two are the range of a distribution and the standard deviation. The range of the distribution is the maximum value minus the minimum value. The standard deviation calculation will be discussed in another video. An outlier is an observation that lies outside the overall pattern of the distribution. There are formal, precise definitions for identifying outliers, but it's enough for now to note that outliers can have extreme effects on measures of spread. Most statistical techniques require normal distributions, so it's useful to consider some of the characteristics of those particular distributions. A normal curve is perfectly bell-shaped, has a vertical line of symmetry, is centered at the mean, which equals the median due to symmetry, and its inflection points, where the shape of the curve changes, occur at a horizontal distance of sigma from the center as shown in the diagram. The notation for a normal distribution with mean mu and standard deviation sigma is an n followed by a mu, comma, sigma in parentheses. One of the most useful rules of thumb concerning normal distribution is called the 68-95-99.7 rule. This rule says that in a normal distribution, about 68% of all observations fall within one standard deviation of the mean. About 95% fall within two standard deviations of the mean. And virtually all, or about 99.7% of all observations, fall within 3 standard deviations of the mean. Thus, it is easy to predict the likelihood of an observation falling in a particular range when the underlying distribution is normal.